Hi, I just wanted to say thank you for watching my video, and there's a few things I wanted to explain beforehand because it's kind of hard to show them without students. I do have them in my lesson plans, but there's a couple things I just want to touch upon. During the lesson, I have a lot of these different worksheets and things. They should all be posted up on the projector for the students to see. I don't have a projector, so I don't really have a great way of showing that. Another thing is for classroom management, what I'm going to do is during the, one of the things I'm going to do during the guided practice is I'm going to have the students, what they're going to do is work with their shoulder partners at their desk for 90 seconds to solve a problem. And then they're going to move to the carpet to work with the class to solve the problem, kind of go over what they did. And then they'll go back to their desks for 90 seconds to work on the next problem. That's something that my co-op teacher suggested I do after my first lesson. I did it in my second lesson and it seemed to really work. But once again, it's really hard to show that without students. And then one of the last things is during my I do, I would usually use my I do to judge how well my students are doing. Because I have a few questions for them and to work through, show my examples to see how they're understanding it. I would use that time to determine how many examples I really need to use in order to have them fully understand it or the best that I think that they can. But I don't have students to judge on how they're doing with it, so I can't really determine if I need to kind of break it down more or if they're just really understanding it so we can just get through it fast. No students, I can't really determine that, so that's just something that I wanted to explain. I have it in my lesson plan that I would do that, but since I can't really show it in my lesson, I just wanted to mention it. All right, so I guess I will get started. Okay, so hello class, my name is Ms. D, and today we're going to be going over fractions again. So who can tell me what we remember about working with fractions last time? I mean, adding fractions with like denominators. Who can tell me? That's right. Okay, so adding fractions with like denominators, what we do is we keep the denominators since they're like denominators. We just move it over. So if we have a fraction like, for example, it's going to be 5/8 plus 2/8. So we're going to keep the eighths the same. The denominators will stay the same, and we're going to add the numerators. So the 5 and the 2 will be added. We'll get 7/8 as your answer. Okay, we're going to kind of go over that a little bit more. So what can you guys tell me about fractions though? How do we use fractions every day? Who has an example of fractions that they've used, that they've seen their parents use fractions or they've done themselves? Okay, yeah, that's a great example that you had pizza the other night and you knew there were 8 slices, but you guys ate 3 of the slices. So there was 5/8 of the pizza left. So what is that kind of an example for why fractions are important? Anyone have an idea? Okay, so the reason fractions are really important, just like that pizza, we can use them as a form of measurement. So we use fractions to know there's 5/8 of the pizza left. And you can use fractions like when you're measuring something. Let's say I measure this pen with a ruler, and we know this is 5 inches and 5 3/4 of an inch. So it's not a full 6 inches, but it's close to 6 inches. That's just a way that we can do it. Another real life example is if you're going to move furniture into your bedroom. You need to be able to measure your furniture to figure out if it's going to fit, if it's going to fit through the door, or if it's going to be like way too big for your room. All right, guys, so what we are going to be doing is I want you to get out your math notebooks. So basically what I'm going to be writing up and that you're going to see up on the board, I want you to be writing in your math notebooks, for example, okay, and taking notes. Okay, so first problem that we're going to do here, that I'm going to do, is an example of what we were doing last time, okay? So this is going to be adding fractions with like denominators. Oh, and also, guys, I forgot to kind of mention what we're going to be doing today. What we are going to be doing is I'm going to, like I just said, you're going to get your math notebooks. We're going to take some notes. I'm going to show you guys some example problems up on the board. You're going to take some definitions. And then we are going to do a 5-question worksheet together as a class. And then after that, you guys are going to do an independent worksheet. It's about 10 questions. You're going to be doing it all by yourself. And then you're going to have an exit ticket at the very end of class. Okay? So make sure you guys have your math notebooks out, and we're going to start working on this problem. So the first problem is just a review of what we did last time. So remember, we did adding fractions with like denominators. Okay, so our example here that we have, the denominators are 8. Okay, so how are we going to add this? Who remembers? Yeah, that's perfect. That's right on. So we're going to keep the denominators the same. It's just going to move over. So we're going to have a denominator of 8, and then we're going to add our tops. So what's 4 plus 3? That's right. So 4 plus 3 is 7. So we know we're going to have 7/8. Okay? So now we are going to go on, we're going to start adding fractions with the denominators of 10 and a 100. Okay? Now, as you guys look on the board and you see the fraction, 10 and 100 are obviously not like denominators. Okay? So how are we going to make these like denominators here? Any idea? Anybody? It's okay, guys. So that's what we're going to learn today. It's okay that you guys don't understand yet. So I wrote this definition. It's up on the projector. I want you guys to copy this into your math notebooks, the definition and the example I gave. Okay? So this is what we're going to do is we're going to turn our 4/10 into an equivalent fraction. Okay? An equivalent fraction is fractions with different numerators and denominators that represent the same value. Okay, so make sure you guys have that written in your math notebook. The example I gave is 1/2 over 5 is equal to 5/10. Okay, so what it is 1 is half of 2. Okay, so 5 is half of 10. So both fractions are showing 1/2. So that is why they're equivalent fractions. Okay. So what we want to do with our 4/10 is we want to make an equivalent fraction that has a like denominator of 100, so we can add the two, but it's still the same as 4/10, okay? So what we're going to do to achieve this is we're going to times both 4 and 10 by 10, okay? So remember, look up on the projector for what I'm doing and make sure that you're copying this into your math notes, okay? So like I said, we are going to times 4 by 10 and 10 by 10, okay? So what's 4 times 10, guys? All right, perfect. So 4 times 10 is 40, okay? And then what's 10 times 10? That's 100, okay? Perfect. So what's our equivalent fraction? Our equivalent fraction is 40 over 100. Okay, so now what we're going to do is we're going to add 40 over 100 to 50 over 100. Simple enough. That's like what we were doing in our last math lesson. We just kind of reviewed. Now our fractions have like denominators. They're both 100, so we can easily add them, okay? So does anyone know what 40 plus 50 is? That's right, it's 90. Perfect. And then what are we going to do with our denominators? That's right, we're just going to keep the denominators and move it over, so it'll be 100. So our final answer is 90 over 100. Okay? So that's perfect. And now we're going to move on to our next one. So for our next problem, we have 210 over 32 over 100. Okay? So what are we going to do here? Any ideas? That's right. So we're going to turn it into an equivalent fraction. Like we said before, an equivalent fraction is a fraction with different numerators and denominators that represents the same value. Okay? So it's basically the same fraction but different. So to make this into an equivalent fraction, what are we going to do? That's right. We're going to times it by 10. So we're going to times 2 by 10, and we're going to times 10 by 10, okay? So make sure you guys are writing this in your notebooks too, like I said. So What's 2 times 10? That's right, it's 20. What's 10 times 10? Perfect, it's 100. So we're going to add 2 times, so what's our new fraction here? It's 20 over 100 is our new fraction because we times the 2 by 10 and the 10 by 10. Now that we have this new fraction, can we add it? That's right, guys, we seem to really be getting this. We can add it. Okay, so we're going to add it to our 32 over 100. Now, why can we add it? That's right, because they have like denominators now. Now that we changed 2 tenths to its equivalent fraction of 20 tenths, that we now have like denominators, so we can add. So what are we going to do here? So what is our denominator? We should all know that one. That's right, it's 100, okay? So we're just gonna move our denominator over. So what is our numerator? What's 20 plus 32? Any ideas? That's right, it's 52. So our new numerator is 52. So our total answer here is 52 over 100. All right, you guys did perfect. So just to kind of review what we did, we made an equivalent fraction by timesing both the top and the bottom by 10 to get 20 over 100. And then we're going to add our new equivalent fraction to our original 32 over 100. So then 20 over 100 plus 32 over 100 is going to equal 52 over 100. All right, you guys are doing awesome and seem to really understand this. So we are going to move on to our next activity here. All right, so I'm going to hand out everybody this worksheet, okay? And I want you to get your clipboards out, and you're going to put your worksheet on your clipboard. So what we're going to do is you're going to work with your shoulder partners to kind of complete this worksheet, and we're going to work as a class. So you're going to have your clipboards, and you're going to have it, sorry, lost train of thought. You're going to have your papers on your clipboards. You're going to work with your shoulder partners to solve the first question right here. You're going to have 90 seconds to solve it, and then I'm going to have you guys come down to the carpet. And at the carpet, we are going to work on how you got your answer, okay, and kind of work through it together. And then after that, you'll go back to your desk with your shoulder partner, and you're going to work on the next one and so on until we get through the whole worksheet, okay? So, all right, so you guys are going to have 90 seconds. I'm going to be timing you, and you can get started. Finish that first problem. All right, guys, 45 seconds is up, so make sure you're really getting it done. Half your time is up. All right, that's 90 seconds, so I want everyone to bring their worksheet on their clipboards and come down to the carpet with your partners, and let's figure out the first problem. All right, who can tell me what is the first step that we're going to take in this first problem? So well, first, before we talk about steps, can somebody read me the problem? All right, go ahead, Amanda. Perfect, yeah. So 3/10 plus 20 over 100. Okay, so what's our first thing that we're going to do? That's right, Jason. We're going to make 3/10 into an equivalent fraction so we can add it to 20 over 100. That's perfect. I like how you put that. So we're going to take, how are we going to do 3/10 and make an equivalent fraction to 100? We're going to times it by 10. So can I just times the bottom half and not times the top half? I mean, I just want the denominator, so can I just times the bottom without timesing the top? No, I can't, because I need to be able to, whatever I do to the bottom has to be done to the top, okay? So I'm going to times the 10 by 10, and I'm going to times the 3 by 10, okay? So who can tell me what they got here when they did the times? Perfect, yeah, so 30 over 100, yes, I said that wrong, thank you for correcting me. So we have 30 over 100, now what do we do? Perfect, yeah, so we're going to add the 30 to the 20 over 100, so now that we have the equivalent fraction, from 3/10, we have the equivalent fraction of 30 over 100, which has the same denominator as 20 over 100, we can add them. So what was the answer? How about you two, someone I haven't heard from, Vincent and Chase. Can you guys tell me what you got? Perfect, yeah, 50 over 100 should be your answer. That's perfect. All right, so I want you to go back to your seats and go back to your desk, work with your shoulder partner. You got 90 more seconds to work on the next question, okay? And go. All right, guys, 45 seconds is up, so that's half your time. Make sure you're getting this done. All right, that's 90 seconds. So I want everyone to bring their clipboards, come with their partners, come back to the carpet. All right, so again, who would like to read the problem? Maybe someone I haven't heard of. Get that close. All right, go for it. Yeah, read it. Oh, you're perfect. Yeah, 8 tenths plus 10 100ths. Perfect. Yeah. So what is our first step here? Okay, so our first step is not to add the fractions. You're a little bit off, but I'm glad you said that because it's a great example. So we're not going to just add the fractions first. Can someone answer for me why we don't just add the fractions like we would if in the other problems we're doing? That's right, they don't have like denominators. Okay, so we have the denominators of 10 and we have the denominator of 100. So they are not like, so we cannot just add them. How do we make these like denominators? All right, Jose, what's that? Perfect, yeah. So we are going to make an equivalent fraction, just like Jose just said. That's perfect. But how do we make it an equivalent fraction? Yes, we're going to times them by 10. And like I said before, can we just times the top? No, we can't just times the top. Whatever we do to the top has to be done to the bottom. Whatever we do to the bottom has to be done to the top. Okay? So we're going to times 10 by 10, and we're going to times 8 by 10. Okay, just like you were saying. So who can tell me what they got? What's 8 times 10? 80, perfect. And 10 times 10? 100. All right, can we finally add these now? Yes, we can, because we finally have like denominators. So we have 80 over 10 plus 10 over 100. I'm sorry, not 80 over 10. We have 80 over 100, and we have 10 over 100, okay? So we can finally add them. So what's our final result here? What's the final answer we got, guys? That's right, we got 90 over 100 is perfect. All right, so everyone should have 90 over 100. Is there any questions? Anyone didn't understand all the parts that we did? No? Okay, perfect. All right, so you have another 90 seconds. So go back to your desk with your shoulder partners, work on the next problem, and I'll see you in 90 seconds. All right, 45 seconds is up. Half your time, guys. All right, and there's 90 seconds. Let's come back to the carpet. All right, so who would like to read the problem for me? Perfect, go ahead, read it. Awesome, 2 tenths plus 40 over 100, okay? What's our first step here? Who can tell me? All right, go for it, Anna. That's right, we are gonna make an equivalent fraction by timesing the top and the bottom by 10. So we're gonna times the numerator 2 and the denominator 10 by 10, okay? So we're going to times both by 10. Now, who can tell me what they got when they times both the bottom and top by 10? Awesome, yeah, so we should have gone 20 over 100. Can we add 20 to 100? Can we add that to 40 over 100? Yes, we can. All right, so let's add 20 over 100 to 40 over 100. So who can tell me what they got? Anybody want to tell me what they got? Sure, go for it. What'd you get? 60 over 100. That's perfect. So that's your final answer, guys, for number 3, is you should have gotten 60 over 100. All right, let's move on to the next one. Go back to your desk with your shoulder partners. You'll have another 90 seconds. All right, 45 seconds is up. All right, and there goes 90 again. So let's come back to the carpet and work on this together. So, what is our first step here? We're going to make an equivalent fraction. Perfect. Which one? What are we going to times here to make an equivalent fraction? It's not 40 over 100. Okay. So I know this one is a little bit more confusing because usually the last few problems that we've done, the fraction that we need to make equivalent is over on the right side, however you're looking at it. It's usually the front one, okay? But right now, it's not the front one, which that's okay. There's no necessarily order that you're gonna be in. Here's something I didn't really explain, but how do we know which one we're gonna turn into the equivalent fraction? Okay, because it has the 10, yeah, that's a great observation. And for right now, that is why we're doing, but when we learn how to do, how to add fractions that don't have 110, but you still have to make them equivalent, it's just easiest you can only pick the lower number because the lower number can get bigger to match the bigger number because 100 is obviously the bigger number. So 100 cannot come down to 10. But 10 can go to 100, okay? So that's why we're just going to pick the smaller fraction, all right? So who would like to give another whack what we're going to make equivalent here? Yeah, perfect. So we're going to make 5 out of 10. We're going to turn it into an equivalent fraction so we can add 40 over 100, all right? So how are we going to do that? That's right, we're going to times it by 10. So 5 times by 10, and we're going to times 10 by 10. So what fraction did we get? That's right, 50 over 100 is perfect, okay? Can we add now? Yes, we can. You guys are really getting the hang of this. Or we can add 40 over 100 to 50 over 100. And what do we get? That's right. So how do we get that? How do we get that answer, though? Can someone explain it to me? I know that we get 90 over 100, but how do we get 90 over 100? Perfect, yeah. So the hundreds stay the same like denominator, so our denominator is going to be 100. And our numerators, we're going to add to get 90. That's perfect. So we should have 90 over 100, okay? Any questions on that one? Anything anyone didn't really understand? Okay. So for the next one, our very last one, you're going to have another 90 seconds to work with your shoulder partner. So go back to your desk. All right, so that is 90 seconds. So come back to the carpet. Let's work on this together. So who can read the fraction for me? All right, go for it. That's right, 6 tenths plus 30 over 100. That's our question here. What are we going to do here? Yeah, we're going to make an equivalent fraction by timesing 6 tenths, both the numerator and the denominator, by 10. Okay? So we're going to times both by 10. Who can tell me what they got? Yeah, so it's 60 over 100. Now, can we add that to 30 over 100? Yes, we can. Good answer. So 30 over 100. We're going to add 60 over 100 to 30 over 100. What's our final answer? Who can tell me? That's right. Once again, it's 90 over 100. All right, perfect. You guys really seem to get the hang of this. So I want you to take this worksheet, and you're going to fold it in half. Okay, you're going to fold it in half, and I just want you to stick it in your math notebook for now, okay? You can just put it in there right next to the notes that you took earlier, okay? So now what I'm going to do is I'm going to pass out this worksheet, okay? So the worksheet we're just finishing, that should be put in your notebooks. I want your clipboards to be put back in their homes, and I'm going to hand out this worksheet. Okay, now that everyone has this worksheet, you can see there's 10 questions. You are going to be working on this individually, so there should be no talking in the classroom. This is an individual assignment. While you're working on this worksheet, I'm going to be walking around the classroom so I can help. Just raise your hand, and I'll be more than happy to help you out with it, okay? Once you are done with this worksheet, I want you to turn it into the basket that's in the front of the classroom, okay? So you're gonna turn this worksheet into the basket, and what you're gonna do is right next to the basket, you should be able to see your exit slips, okay? So I want you to grab an exit slip. You are going to answer all 3 questions, and then you're gonna come walk it up to me when you're done, okay? All right, guys, I think everyone has turned into your exit slips. You guys did a great job today. Thank you for being so cooperative.